Hello and welcome to another edition of Python for PL/SQL developers. So far we talked about the Python language, the basics of it, the conditional logic, the loops, different kind of collections. We also saw the file handling methods as well and how we can use this for to do all kinds of data crunching. But if you're a PL/SQL developers, you probably want to know a lot more about data crunching as opposed to anything else. And if you want to be a data scientist, data crunching is of course a must. Python has a lot of powerful features like collections and iterating through the collections, etc. to do the data crunching, which is very good, but it's not adequate most of the time. Mostly because if you do some data crunching, you're probably talking about a lot of data, not just a little bit. So to do a lot of data crunching, you got to have some more powerful tools. Fortunately, people have developed modules that go with it, and these modules are available as a part of Python, so you can do some powerful data crunching. Remember, modules, they're very similar to PL/SQL packages. So, and these modules are available. You can just have to install them and then start using it. So today we'll be talking about some of these modules for data crunching. Specifically, we will talk about NumPy, Pandas, which is another data crunching package, Pandas data reader, Matplotlib, which is a graphing software, graphing module, and most likely, if you're a PL/SQL developer, so you want to connect to the Oracle database to do get some data out or data in, so you can do some manipulations. And we'll talk about SQL Alchemist, which is general purpose data manipulation tool with any kind of database, and more specifically for Oracle is a module called CX Oracle, and we'll cover that as well. So without further ado, let us jump into the first one. All these packages as mentioned here are not actually installed by default, so you have to install them. How do you install them? Actually really simple. Python has something called a Python integration package, I'm sorry, Python package index, which is a web page containing all the different modules which is available for you to install. And best thing to do, just go to the website and see this yourself. You just go to the website. It's pypi.python.org. That shows you all the different packages we talked about here. More specifically, we'll talk about how to install some of the packages we are interested in. And the best thing to do is this way. You say Python -m pip, then whatever you want to install, the package, it has to come here. I have already installed a few packages, so I can't really install it. Let me show you an example of what I installed here. So let's say I want to install a package called Oracle space db space query. Oh, sorry about that. Oracle is called Oracle db query install. I missed that. All right. It's go through a few things and it says requirement already satisfied because I already did this requirement. So I can't just reinstall it. If I want to find out what I have installed so far, I'll simply say pip list, and that shows me what are the different things I have installed. But this is how you do it. Simply say Python -m, that stands for load the module, pip install, and whatever the module name comes here. In this, I have to put Pandas and press enter, it will do that, or NumPy, or CX Oracle, or SQL Alchemy, etc. So all those things you can do it here. Since I have already installed it, I can't really do it one more time. So I hope you have installed that and without any kind of problems and go through it. Let's start with the first one called NumPy. Why do we need NumPy and what problems we have in the typical collections? NumPy is a data crunching tool, data crunching application. So let's say start the first NumPy. Start with Python as usual. Remember, to use a module, you have to import it. So it's a import NumPy. Optionally, you can import as an alias. So you can say NumPy as NP. You can do that. That's how. So instead of using the functions as numpy dot function name, you simply have to put np dot the function name. That's how it is. So what exactly is numpy used for? Let's see. Let's see a typical array in Python. Suppose you have a list of account balances. So you'll say something like this: 1, 2, 3, 4, 5. Just to be very, very simple. This is some kind of account balance for 5 different accounts starting with 0. Okay, so each position has a balance account. This is good. Now suppose you want to give everybody a 50% raise. That means you want to multiply the balance here, each balance by 1.5. So this is what we do. So new bal equal to, bal into 1.5. Suppose you do this. You get an error right away. It simply says you cannot multiply a sequence. By the way, sequence is nothing but a collection in Python. You cannot multiply a sequence by a type of int float. Basically, you cannot just multiply a scalar to a array like this to come to so that the scalar would apply to each of the elements. You simply cannot do that. This is why the mistakes would happen. Actually, there's one more thing you have to be careful about. You can actually multiply an integer. What happens then? See what happens then. What Python simply does is, if you multiply by 2, it simply repeats the same array as it does. So that's not exactly what you want. You want to multiply this by 2 or multiply by 1.5, whatever is appropriate. Each element has to be multiplied by that. So how do you do it? Well, typically in Python, if you want to do it, you have no choice but to do something like this. So for I in range length, say bal. So you say bal I equal to bal I multiplied by 1.2 or something like that. And that's it. And now bal will be, if you see, that will make it multiply that by 1.2. Now this is okay for a very small array or something very simple like this. It may not be feasible to do in an extremely long array or some kind of a complex calculation. You really want to do something simple like this, 1.5. So how do you do it? This is where NumPy comes into picture. What you have to do is that you have to create a new array called a NumPy array. That's different from a regular Python array. And then it will become very, very simple. Let's see how we do this. Just to differentiate between the variables, I'm going to use the variable name with a prefix of np to show this is a NumPy variable. So npbal equal to, let me see this how I do it, array np.array. Remember, that means it's a function in the module called NumPy. And NumPy I have defined right here as import as np. So I don't have to give NumPy dot that function name. I simply have to give the alias name called np. So np dot array, and this is a function, so I have to pass an argument to the function, and the argument I will pass is the list 1, 2, 3, 4, 5, and the parenthesis to say this is the end of my argument. This is it. So if I do this np bal, look at this. This is an array 1, 2, 3, 4, 5. This shows you this is a NumPy array. All right. So now I want to multiply this each element by 1.5. Now I see what happens. np underscore bal multiply this by 1.5. That's it. You simply got the 1.5 right there. No problems at all. Remember, I could not do this for a regular Python array. It says I can do this, but in NumPy array, I can easily do it. And that's probably one of the most powerful things. See what I can do, all those things. I can even do multiply this by 2, and it will simply multiply by 2 each element. Remember when I did this on a regular Python array, it actually repeated that. It didn't actually multiply anything at all. It simply repeated that. That's not something that would happen on the NumPy array. So this was just a simple thing to show the power of NumPy and what you can do with this. And this will be very, very helpful. Actually, this power doesn't stop right here. You can do a few other things. Take, for example, this balance. Same thing we had here. Say balance. Just maybe you reset the balance back to what we had before. Balance equal to 1, 2, 3, 4, 5. Let's say instead of multiplying a single value to all the variables, I want to multiply a multiplier. Like say each element has to be multiplied in a different number. Okay, so let's me call that mult. This multiplier equal to say 5 comma 10 comma 5 comma 10 comma 10. Suppose that means 1 should be multiplied by 5, 2 by 10, 3 by 5, and so on and so forth. All right, so this is bal and multiply. When I do this bal multiply, sorry, BAL multiply by mult, you can't simply multiply an array with another array. You just cannot do it. Then how do you do it? Well, you can write this complex calculation like this we saw before. So for I in range equal to this, and say this one bal equal to bal of I equal to bal of I multiplied by mult of I, and so on and so forth. You have to do this way, and then of course it will multiply that by that much amount. Again, this could be simple if it is very small array. If it is an extremely complex array or the multiplications are complex, it's not going to work out very well. Well, this is a piece of cake in NumPy. Let's see how that is done. Once again, let me go back to as a NumPy array and make sure that I just simply convert my typical array to NumPy array. 1, 2, 3, 4, 5. I got it. And I will simply also call np underscore mult in NumPy array. And here I will just make sure I get this value. This is it. Then what I have to do is np underscore bal multiply by np underscore mult. There you go. It multiplies each one and gives me another NumPy array. So this is one of the best features of NumPy arrays as compared to regular Python arrays. But be very careful about that one. NumPy arrays do not behave the exact same way as Python arrays. For example, if I want to simply add them together, say if I just add up two regular Python arrays, say balance plus mult, all Python does is simply add them up to become a bigger array. Not add each element, but to combine all the elements together into another array. So you can see that this is the first bal, and then this is the next the multiplier. If you do the same thing for NumPy array, it will simply add the elements together. So if I do this np bal plus np mult, it will simply add this together, as opposed to a Python array which will simply concatenate the two different lists into another list. And this way NumPy won't do that. So just to be careful about the behavior of this NumPy array. So NumPy arrays are very powerful when you want to do some array and element to element analysis in that one. So very, very useful to do all those things. But that's not it though. There are a few other things. One, for example, one thing, let's say this NumPy array. So let's just make sure that I have a NumPy array, NumPy balance 1, 2, 3, 4, 5. If I want to find out how many of this are more than 3, suppose, It shows you very clearly 1, 2, 3, 4, 5. The first one is not more than 3. That's why it's false. That's one. The second one is also false. Third one is false. Fourth one is 4. True. True. This is very, very useful for showing which values are based on Boolean variables. You can do that way. And so now, so how do you access a NumPy? Well, it's really simple. Well, let's do some more thing. Let's say you already have a Python array. Can you convert that to NumPy array? Of course. Look at how we define the NumPy array. It's this way, number multiplier. But you already have a Python variable as a multiplier. I don't have to retype it. I can simply convert this Python array to a NumPy array. So how do I do this? Very simple thing. I will simply say np mult equal to np.array mult. Pass it on. That's it. That's what it gives me array. This is very, very useful that way. How do we access a NumPy array? Well, exactly the same way you access a regular Python array. Remember, to access a Python array, you have to put by positions, and the positions start with 0. So if I want to find out the first element of this array, what do? I simply say np mult 0. This is the first one. Then if I go to second one, actually just for the third one. For the second one, I put 1, this is 10, and 5, and 10, and so on and so forth. This is how I do this. So this is the thing about NumPy array. And you can also do this one. If you do this one, object is not callable. That's because in this particular NumPy array, I haven't actually, this is not a list. This is not a tuple. That's the reason why I can just group this np equal to 0. So let's see a few more things about NumPy array. One of the interesting things about NumPy array is I don't have to even specify any kind of an index. So let's just go back to another one. NP balance 1, 2, 3, 4, 5. If I want to find out how many of this are NP of more than 3, I got this false, 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 true, true. But what if I want to find out how many of these elements are more than 3, but show me the elements, not just simply say false, false, true, true, true. I don't want that way. So to do that, I simply have to say in an index balance, np underscore balance is greater than 3. Now this is an interesting indication. You can see that in the index I didn't put an integer like 0, 1, 2, 3 just to put a position. Instead, I simply put a Boolean expression, which means n-bal is more than 3. See what happens here. It gives me 4 and 5, because 4 and 5 are the two elements which satisfy this Boolean expression right here. And that's what gives me that thing. That's the best thing about the NumPy. You can access the elements using a Boolean expression as well, and not just anything else. But that's not the end of it though. There are a few other things. So far we talked about a single element, single array. But most real life problems, you won't see any single array. For example, let's say I have an array called products array. So let me just show you that how to look at this product array. For that, I will show you the sorry about that. So that I have to show you the web page. I want to show you the specific package here. Okay, there you go. Python for SQL developer. This is my thing. So here, what I want to do show you is this one. This is how the product ID looks like. So it's product ID 0, 1, 2, 3, etc. And the cells is 1000, 2000, 3000, and 4000. How do I represent it in a NumPy array? Very simple thing. What I have to do is I will simply say cells equal to 1000, 2000, 3000, and 4000. Very good. That's what it is. But do you think in real life you'll get some data like this, such a simple one-dimensional array? Most likely not. Most data will come in some kind of a tabular format. For example, your data may come in this format. Here, the data will be broken up into multiple quarters. Quarter 1, so product 0, quarter 1, the sales is 200. Quarter 2, the sales of the same product 0 is 300. Quarter 3, 275. Quarter 4, 225. So if you add that up, it becomes 1000, which is what was here. But it's actually more granular in this case. This is a two-dimensional array if you think about it. You have one dimension of all the products, right? Sorry, this way. And you have another dimension of all the quarters is this way. It's a two-dimensional array. It's also very easy to do in Python. You simply do this. Let me put this way. I'm sorry. My fault. NP done. So if you do cells, it's an array of 200, 300, 275, 225. This is one array. You can see that. It starts, the parenthesis starts here all the way up to here. The second array is this. The third array is this. And the fourth array is this. And we have two square brackets enclosing this entire set of four arrays to create another array. So that's how we have defined a two-dimensional arrays. The cells number. Once again, let's go back here. This is to represent this thing we saw here. So for quarters and products, this is what we have defined here. This is how we define the array. So far, so good. All right. So this is just to make sure that this is actually a two-dimensional array. Of course, we know that because looking at it, but sometimes it might not be that simple when you look at extremely long and big arrays. So what you have to do, or it is an attribute called ndim. So you can show ndim. That shows you 2. This is confirming that this is a two-dimensional array. How do you access each of the elements? Well, it's actually really simple. So let's say you want to find out access this first number over here. So you do cells 0, 0. There you go, 200. If you do second number of this, 300 is right here. 0. So first 0 gives you this, and the second 0 gives you the position within that itself. So let's say I want to find out this 600 over here. Remember, this is the first array, second array, and the third array. So I have to do cells 2, and this number is the 0th position. So 0, 600. That's how I actually go and do it. The dimensions of the way the array is organized, a multidimensional array is organized, it's called a shape in NumPy. If you want to find out the shape of this, shape 4 by 4, because 4 across and 4 down, that's why it's called 4 by 4. Of course, things will become different when you have different kinds of array. All right, so far so good. However, it's highly unlikely that you will get a two-dimensional array all the time. For example, in this case, we saw products and the quarters. What if it now changes and they want to give you product, quarter, and how it varies across a territory, for example, north, south, east, west, etc., the territory or the sales zones, and how it actually makes a difference. So what do you do in that case? Then in that case, you have to add yet another dimension called territory. That becomes a little bit complex, but not for NumPy. Just when you define another dimension, all you have to do is simply create an array for that. So this is how we create this array. So NP array, do it this way. So let me just make sure that we get it. Yep, this is thing. So if you look at this one here, this is one array. This is the second array, and third and fourth. This is enclosed by the square bracket over here and the square bracket over here. So this is the first array in the next dimension. Similarly, all this 1, 2, 3, 4, all these 4 different arrays in the second dimension are enclosed by these 2 square brackets. This is the third dimension. This is how you create multi-dimensional array. Just to make sure that's is the 3-dimensional array, we can just confirm that by using, if you remember, which is shape 4 by 4 by 4, and the other one is not a ndim. That gives you 3. So this way you can create a 4th dimension, a 5th dimension, and so on and so forth. It's not limited to only 3 dimensions. Once again, how do I access this? Just 100 over here. See that this is the first array. This one. Right? This is the second array. And so on and so forth. So if I want to access this 150 over here, this is a second array. I have to go to the second array. In that, I have to go to this 150 over here, and that's what it gives me. So I have to do this one. The second, this is the 150 is to 1, so 1, and inside that, this is the first one, so 0, 150. That's how we go and get that. So this is an excellent way to create multi-dimensional arrays. But you might ask the question, why create something? Well, once you create it on a multi-dimensional array, it kind of resembles a relational table, if you think about it. Actually, it resembles more like a data warehouse cube. You can create any dimensions as you want to. But the whole point of creating a dimensional cube or dimensional array like that, so you can do some statistical analysis on that one, right? So how do you do analysis? Let's say something very simple. What if somebody asks you, what is my total sales? So of course you can do sales 0, 0, 0 plus sales 0, 0, 1, and so on, so plus, and so on and so forth. Of course it's cumbersome. It's not going to work very well. In fact, if you don't know, if you have to can now keep on doing it, particularly for big multidimensional arrays. Fortunately, NumPy has a very simple solution. You simply say sum. That's it. It's a function. Actually, it's a method in that type that gives you the entire sum. Very simple. Okay, this is some simple sum. If you want to find out the average of this, average, or actually mean, the function, that one gives you average function. You can also give, it's another type called, it's called a function, specific function called mean. So you can say it this way as well. Same thing. This basically says sales.mean is this here, the mean is a method in the type called this NumPy type. In this case, this mean is a function in the module. Either way, they produce the same results. What if somebody wants to try to find out, I don't want to find the mean, I want to find out for a product 0, what is the average sales? Well, that's a very interesting question. That means you want to average this first array right here, not just an entire average itself. You can do that. You simply say sales 0 dot mean. That's it. That gives you the average for the first one. Similarly, the second product this way, third product and so on and so forth. That's what gives you array. This is a very simple thing to do. If you want to find out for all the different products what is the mean, you can do that very simple calculation. So for I in range length of cells, see that length of cells, this also looks like just typical Python array. So print cells I dot min. That's it. That gives you one. If you want to be a little bit more fancier, you can do this way as well. Print, say, mean cells of product plus I, actually not product, comma, I, comma, equal to, comma. This is it. You can have it fancier as well. So this is something you can do very well. But you don't have to do this array and all that thing complex. What it gives you, suppose somebody gives you a slightly different analysis. In this case, I just simply said, give me the average of the first one, the second one, third one, and fourth one, all that. What if somebody gives you just a little bit differently? Give me the average of the sales for a specific region or a territory, like a north. Not just not products, all the products of all the quarters for the north region. That's a little bit different. Or somebody will ask you, give me average for sales for first quarter across all the products and all the different regions, not specific region. So that means you can't just rely on this sales 0 over here because it's not going to work. This is something. So how does it work in Python? I'm saying NumPy. It's actually really simple. But just to make it a little bit comprehensible and easy to understand, let me define another NumPy array with just simply 2 dimensions. That way it will help you to understand the concept very well. So that the dimensions are this way. This is the dimension. Control C this and this. Oh, I'm sorry. NumPy is not NumPy. It's actually NP because that's what I have defined as NP. Okay. All right. The way I describe this, define this array is really simple: 1 1, 1 2, 1 3, 1 4. Then I repeated the same numbers: 2 1, 2 2, 2 3, 2 4, 3 1, 3 2, 3 3, 3 4, etc. And I just kept that at only 3 rows or 3 arrays in there to show you that the shape will be that way as well. So if I do a dot shape 3 comma 4, there are 3 rows and 4 columns. That's what I think meant. Okay, so you got these things numbers. We saw before a dot says sum. That gives you 270. It adds this all together. You can also put here. You can see what if I want to put a sum of these things? We saw that before. I can do this 0, 50. How wide is 50? Look at this one here. 11, 12. That comes to like 23. 26, 36, 40, and 50. This one is 0. 11 plus 12 plus 13 plus 14. And I don't have to guess it. I can just simply type it here. And remember, Python simply gives you like a calculator as well. It's just whatever you type it here, it gives you the result right away. Similarly, if I do A1 sum, it gives you the sum of these 4 numbers here. And if I do a 2 sum, it gives you 3 numbers here. So far, so good. What if you want to find out the sum of this number, and this number? How exactly will that work? If you, well, then something like this you have to do. A1, sorry, A0, 0, then plus A1, 0, plus A2, 0, and so on and so forth. This is cumbersome. You have to know how many rows are there, and then keep one, then keep on repeating for this one, and this one, and this one, and so on and so forth. If you becomes a multi-dimensional array, this becomes even complex and not cumbersome to manage that. You don't have to. That's the best part of a NumPy, is that it allows you to do this slicing or dicing or a summarization across any dimension as you want. In NumPy, we call that axis. So each axis is defined, and that's how we get it. So let's see how we do the axis. So A dot sum, we saw that before, 270, but I can say axis equal to 0. Look what I got here. When I say axis equal to 0, I got 63. Why 63? Because it simply added up this thing, two things here. So 31, 21, so 11 plus 21 plus 31, 63. That's what the first value here. Second value is 12 plus 22 plus 32. So I got 12 plus 22 plus 32. I got 66. That's my second number right here. Similarly, if I add this up 3, it will give me 69. If I add this 3 up, it will give me 72, and so on and so forth. So I can get this simply by saying sum axis equal to 0. So that's going to give me the numbers like this way. What if I want sum of these numbers, like across the rows? No worries. I simply have to say axis equal to 1. That gives me these numbers. Add this up, 50, add this up, 90, add this 4 up, you get 130 right here. That's how I think. Similarly, in a multi-dimensional array, let's go by multi-dimensional array, which is 3-dimensional array, it becomes really simple. So say sum axis equal to 0. That's the first axis. Sorry. It gives you that. It simply gives you, adds this to here. You can give axis equal to 1 and axis equal to 2, because it's a 3-dimensional array. You can do that, and you can get all these different summarizations as well, which is very, very helpful for data analysis and all that thing. But you don't have to just do only sum. Sometimes other summarizations also helpful and available. Take for example a minimum. So instead of doing sum, you say what is the minimum amount of cells in that axis? Axis equal to 2. So in this, because 50, the other one is 120 over here, so and so on and so forth. So you can do that minimum as well, and so as maximum, and so on and so forth. Sometimes you want to find out the rows, specific rows in the NumPy array. Not sure why would you do that, but let's say you want to do that, and you can access that easily just like a typical Python variable. So you can say for row in cells print row. So that prints each row. In this case, row meaning each of the array, it will keep on printing. You can see the array here 50, 50, 50, 50, 150, 150, 180, 120. So 50, 50, 50, 50, 150, 150, 180, 130. So this first one over here is represented right here. This is the first row, second row, and so on and so forth. So it's very useful that way if you want to show all the rows. But what if you want to show everything in one after other, not in an array? So for example 50, then our next numbers will be 50, then 50, and so on and so forth. You can make something called, you can flatten it. So you can say it this way. It's for row in cells dot flat print row. It shows all the numbers one after other instead of showing as an array. So it might be helpful sometimes just to show that if you want to do some analysis, all the thing. I'm going to stop right here and show that how useful NumPy is. The reason I want to stop right here is that I want to show you the next one, a next important module called Matplotlib. But more than that, we'll combine Matplotlib and NumPy right after this, so you can see how the power each one is. So next one is called Matplotlib. Hopefully you have installed Matplotlib from this or the first one. You got to install that, and once you install that, we are going to use Matplotlib and NumPy. So you can say import. If you haven't done that already, NumPy as np. For Matplotlib, we will not import the entire package because it's too big. We just want to find out only one thing, that is the plotting function. So we're going to say import matplotlib dot pyplot as plt, something really simple. It takes a little bit longer time to load it because it's a huge package. All right, we got that loaded so far. And just to refresh your memory, this is how I did the cells earlier. It's a three-dimensional array, and it represents the cells for each product 0, 1, 2, 3, 4. I'm sorry, 0, 1, 2, 3, the 4 products across 4 quarters, and then subdivided into 4 different zones: north, south, east, and west. So we got that part, the thing, NP array. And first, for plotting, we need two things. We need an x-axis, we need a y-axis. For x-axis, we want the product numbers 0, 1, 2, 3, 4. Well, we can do this. So we can simply say x equal to just a variable called x np dot array. Here we put 0, 1, 2, 3. Sorry, x, just to make sure we have the x. This is x thing. Good. Now for y-axis, we actually have 4 different products. So the cells will be different for each of the cells, right? So we can just simply say cells. So let's create a variable called y0 for the product 0. We call it y0. That's cells 0, actually sum. Oh, sorry about that. Be cells 0 dot sum. Okay, y0. Similarly, we create another one called y1, another one called y2 for product 2. I'm sorry, product 2, and y3 for product 3. There you go. So let's just make sure we got everything. Yep, y0 and y1, y2. Actually, made a mistake. We want an array for y0, 1, y3, etc. So I'm going to do this. Cells 3. So y0 equal to cells 0, 0. y1 equal to this. Oh. y2 is this. y3 is this. So let's just confirm that. y0 array, good. y2, y3, we got everything here, and x, of course. Now we will do the plotting. First thing we'll do with plotting is plt dot plot, then say X, the first one, Y0. We have to label it, of course. Let's call this label product 0. So I'll do label equal to product 0 and it. See, nothing happens here. Why? Because this is simply giving instructions what I want to plot, not the actual plotting itself. Let me first give all the instructions, then I'll plot. This is 1 y0 axis. Likewise, I have to give y1 as well. I'll give this y2 as well and y3. After everything is complete, I will ask a legend as well. By default, Matplotlib may put legend somewhere I don't like. I want to put this legend in the upper left corner. So I'm going to say plt dot legend location equal to upper left. It's got it. And finally, I'm going to say show me the graph. Plt dot show. And voila, I got a great chart. Now, few things I want to talk about it. One, you see, I didn't install any special package or anything, graphic package, to get this graph. Python did everything and simply sorted the graph right away for me. I put things like the label. It gave the label properly with the specific the lines and etc. I asked it to put in the upper left corner. It did that as well, and gives it. Few things let's see on this one. One is you can see that thing. You can see a zoom to the rectangle. I can zoom it. When I zoom it, it becomes a crosshair. I want to zoom this portion only. So this zooms into this portion. I can even zoom further as well. See the exact value here. Let me see if I don't zoom it. Sorry. If I don't zoom it and say reset original view, it goes back to reset original view. See the last one here, save the figure. If I click on this, it's going to say what do you want to save as. Some specific figure you can save, and this is helpful if you want to save the picture to be sent to somebody else. That is saying. That's so you can see that when I move the pointer with the cursor over this graph, on the bottom right corner I can see the exact values as well, which is useful if you have a huge graph and you want to find out exactly what the value it is. You can just cross along this one. You can manipulate actually many different ways. For example, the colors it chose by itself, but it doesn't have to. You can definitely use a different color. Take for example, say I can have a just like it over here. Let me close this one. The label equal to product 3. Here I can also put color equal to say green, something. I can do that, and then if I show, it simply shows green. You can see that it shows only one line. What happened to the rest of it? What happens is that when you do a show, whatever you have defined before that, that's going to show up, nothing else. In this case, I simply put y3. You can see here, nothing more than that. If I want to show y2 as well, and color equal to red, y1, say product 1, and color equal to say black or something, and then do so. It will give that color as well. It doesn't whatever color I give, it does give you that. What if I wanted to use a bar chart? No worries. All you have to do is that say plt dot bar and say x comma say y0 label equal to product 0, 0, and similarly another bar is will be y1 label equal to product 1, and so on and so forth. And like that you keep on doing it, and then we say plt dot so. The bar chart here comes out as well. So these kind of things you can keep on doing it like that. Matplotlib is very rich in his library. You can create pie charts, you can create different kinds of charts. So it's kind of difficult to go through each and every item of theirs, which will fill up for a complete book by itself. So instead, I ask you to go to the website, and the website is matplotlib.org. And inside that, you can find out the documentation, what are the different types of bar charts you can produce. Great. Next, we cover another data crunching package called Pandas. Pandas stands for Python Data Analysis. So NumPy was good, but it wasn't really adequate for some of the things. And we'll see what some of the things are and how Pandas actually helps in that. Once again, you have to understand that Pandas is not installed by default, so you have to install it. Hopefully you have done that in the beginning of the video itself. Once you have installed that, then you say import Pandas as say PD. There is you have also have to import NumPy, and you have to import matplotlib.py plot as PLT we saw before. So far so good. Pandas provides two different kinds of collections for data analysis, which is very useful. One is called a series, which is nothing but simply a one-dimensional array, nothing more than that. The second one is called a data frame, which is a two-dimensional array. If you know R, statistical programming language, it's the data frame is very similar to that one in Python. Not exactly the same, but very similar. So what is a data frame? Well, here is the deal thing. Let's see the problem we have in the NumPy one. In NumPy, we said here is how this looks like: quarter 1, product 0, etc. This is good. The problem with this is that we actually did not give any labels to any of this. This is something we said positionally what it is, because see, look at this thing, NumPy array here. This NumPy array, of course, represents all these values over here, but it doesn't say for product 0, quarter 1, here is the value. For product 0, quarter 2, here is the value, and so on and so forth. This is something you just have to figure out based on the position of the value in the array, which may not work very well. You need to have some kind of a label to identify correctly. So how do you do this? So this is something you have to do. So for example, in this case, in Pandas case, you have to identify, let's go back there, something like this table. See, products as the column headers, and let's say north, south, east, west, the territories or zones on this thing. All right. So this is how do you do this. This is how do you represent this thing. This is called a data frame in Python. The thing about it, first thing a data frame is that the column headers, they don't actually change a whole lot. You could probably have the rows keep on changing, but column headers don't change. So the column headers is just a one-dimensional array: north, south, east, and west. So what we'll do is that let's call them zones. So you can say zones dot pd dot series within quotes north, south, east, west. I'm sorry, made a mistake. It should be this. Okay. Few things to understand the thing. This is a series because it's a one-dimensional array. So that's why I could define a series on this one. Number one. The word series, the S is in uppercase. Very important, not in lowercase. So you got that. Next, we define the labels of the rows, which is products. So in this case, product 1, product 2, product 3, etc. So we'll say products equal to, you can simply say product, say prod 1, prod 2, prod 3, and so on and so forth. So we got product, we got the list of the series of called north, south, east, west. Then we got the products 1, 2, product 1, product 2, product 3, etc. We can now populate the table we saw here. Let me throw one more thing for your disposal as well. Of course, I can put the values here, but sometimes it may be helpful to create some, say, random values as a test data generator. Pandas has actually not Pandas thing. It actually has even like NumPy has a random number generator, and that is np dot random dot randn, so 4 comma 3. Not only generates random numbers, it generates the random numbers in a certain format. In this case, I put 4 3, so it's going to generate random numbers in 3 columns and 4 rows in this random number this way. We will use these random numbers to populate our the table we just saw it before, that just to throw as a variation itself. So we're going to say data 1 equal to this. So if I show data 1, that's just these numbers over here. This is the array of these numbers. Then we got 3 things. We got the x-axis or the row, the column headers, the y-axis, which is bunch of the row labels, and we have to have the data to fill in everything. So we're going to do 3 things. So here, this is how we define it. This is called a data frame. So let's call the data frame name it df1. You can give it actually anything you want, but it'll say df1. So df1 equal to pd, that's for pandas, dot data frame data 1, comma, we have to give index equal to zones. Index is nothing but, see that thing, remember that the index is nothing but the row labels for that one. Index equal to row zones, and the columns equal to products. Let's just pause a little bit here to see what data 1 is something we defined earlier right here, data 1. Index equal to zones. Where did we define zones here? We defined zones right here. And columns equal to products. And when we define the products over here, we define the products right here. Got that. After we do this, df1. If I do df1, just type df1 and press enter, it's going to show me the data in this format. Prod 1, prod 2, prod 3, prod 4, north, south, east, west, and put the values right here. What if I change my column labels? I don't want to call it the prod 1, prod 2, prod 3 or something. I want to call some meaningful name. Say potato, tomato, tomato, and product 3 is cucumber. Alright. If I do df1, it still shows prod 1, prod 2, prod 3, prod 4, because that's how I've defined my data. Notice I can always change the data, define this way. Potato, tomato, cucumber, etc. All this came up here, which is perfect, which is I can just send the labels and create another data frame this way. If I want to address a specific value, you can see that here it shows me these values. But what is this value? This is a display only. This is not a Python data type or anything for me to actually go and address it. So to do that, I have to do something called values. Then it shows me an array and with these values over here. And of course, once I have an array, I can do a lot of things with the array. For example, let's say I want to increase everything and multiply 10 to each value. All right, no worries. You can say df1 multiply by 10. Every value is multiplied by 10 times here. And I don't have to go through each one of them and update that. Just like we saw in NumPy, because it's a NumPy array at this point. And so on and so forth, values. There is out of the box, it has some basic statistical functions. You can do that by using df describe. It gives you count, which is number of elements in term, which is 4, mean, standard deviation, minimum of 25% of the values. How much is that? And thing, how are 50% values and all the thing, and max and all the thing. It gives you a basic of thing using describe. Just a little careful thing. Describe with a parenthesis after that. If I do this, it becomes a little bit different because it doesn't give you the same describe over here. You simply say describe off this, which is not something we want. We want describe with a parenthesis after this. What if you want to show it differently? For example, potato, tomato, cucumber is columns. You want to show this as rows, and you want to show north, south, east, west as columns. No worries. You can do this thing called T. When you do the T, it transforms it. It's a very powerful function to transform it. You can also say you want to assign to another variable. df2. df2 is this. If you do df2 dot describe, you see, you got same basic statistics, but now across different elements than earlier. Earlier you got through potato, tomato, cucumber, etc. By the way, I know my mistake. I made a mistake in the typo here in potato. So that was just not deliberate. That was just a mistake. What if you have a huge data frame like this? Typically, you would have not this only 3 or 4 lines. So like a df1, it's only 4 lines. You probably have like a millions or billions of lines. It may not be possible to do everything or show everything in one shot. You want to show only a few lines only. You can do that easily using something called head. Only 2. So this is helpful if you give this only the header and the only few lines after that. Similarly, you can do tail. So it gives you the towards the end of it all the values, which is helpful to check really quickly. Here, if you remember the index, which is nothing but the row labels. So if you have forgotten what the indexes are, you can say df minus a index north, south, east, west in this case. And typically in case of a large arrays like this, you wouldn't see everything. You just have to give it index. It will show you specifically what the indexes is have defined as an array too. So if you want to iterate over that, if you wanted to. What if you want to find out what the columns are? Well, columns, potato, tomato, cucumber. That's it. The thing saying on the columns as well. That shows you. So columns, it shows you indexes, which are nothing but the row labels. And row labels keep on adding as the time goes on. If you have used an Excel spreadsheet or any kind of a spreadsheet, sometimes you have to do order a specific column and to see the progression, how the columns have increased and so on and so forth, or short them. How do you short in a data frame like that? It's actually really simple. If you want to short something, say df1 dot sort values tomato. It orders on tomato. You can see the rest of the values actually become different. What if you want to order on cucumber? You can. It's differently sorted. So this is something that's very useful for sorting if you want to do some analysis on that one. But something we talked about how to operate the entire data frame. Sometimes you may need to extract a specific subset of values from it. For example, you may be asked, what is the sales of a product 1 for each territory? Or what are the sales of the North Territory for each product? Well, this is a very small data frame. You can probably take a look and give the answer. But that's not always going to be easy. Sometimes it will be a huge data frame and it's not something you can look into it and give the answer. If you want to give the answer like that, it's actually really simple. You can simply say the index. What is the total sales of tomato? This is what you have to give as an index. There you go. North, south, east, west. It gives you specifically what the tomatoes are. Similarly, if you want to find out what are the sales of different products along east, you have to give this doesn't give you that at all because you can't give this as a row labels. You cannot give as an index. We'll come to that why is not the case and how to access that. But for the time being, let's go a little bit more than that. To do that, find out, you have to give the position of the row. This is 0. I'm sorry. Did I do the df1 correctly? Yes, it is correct. df1 0. So this one gives you the first two rows, 0 and 2, just like a typical Python array. Can you tell me why I had to give 2 here? Although you know that it starts with 0. This is 0th row. This is the 1th row. Why do I have to give 2? If you remember from my first installment, in Python, when you give a range of values, the second value is up to, but not including that number. So in this case, I have given 0:2 means up to 2, but not including 2. So you got this one. I think that's why I got only 2. If I wanted 3 rows, I would give 3 because this is 0, 1, and 2. Up to, but not including 3. That's what I said to give. All right. So this is what, but it's actually more powerful than that. So we saw in NumPy, you can actually use Boolean expressions as an index. So in this case, I got a bunch of numbers, df1. Let me find out which numbers are less than 0. I can do this, df1 less than 0. So it shows me the values that are less than 0. See this NaN, that means not available number. That's more like something like a null in Oracle or SQL. Okay, so let's go back to again accessing the specific rows or columns. We saw before, this is what it works. Tomato. It gave us all the different sales of tomatoes across all the regions. We tried to do this east. So to give the sales of all the products for eastern region, it gave an error. So how do we get that east? Well, we tried a slightly different one using this. But it's not very convenient because we don't know. That's kind of weird to actually give a range all the time like this way. Not a good idea. We want to have specific labels to access. For accessing labels for rows, it's not just this. You have to give df1 dot location. So if you give that, it gives you the location of the column values over here with potato, tomato, and cucumber, and how much sales was done for the eastern region for each row. You can do the same thing for west. Gives the same thing for western region, and so on and so forth. If you have to find out for a specific region and a product, you can do that as well. You can do this way. So western region, comma, tomato. That will give you specifically that region, western region and tomato. How much it is. Right here. Gives you that. With a higher precision, of course. What if you want to find out a slice of, say, for example, df1, a slice of it. So one column and two rows each. So it's like a slice of it. In data frame, you can use another function called iloc. Actually, not a function, attribute of that iloc. And within iloc, you specify from which point to which point, and you have to give it. So this is how we do it. df1 dot iloc as an index. See that? First one 0, 2, and if you remember, what that means is 0 and 1. Remember, up to but not including 2. That means 0 and 1, not including 2, comma 0, comma 3. Suppose we give it. Oh, sorry, too many integers. My fault. 0, comma 3. So this one gave me, this is the columns 0, 1, and 2. 0, 1, and 2. The first one was number of rows 0 and 1. 0 and 1. That gives me those values as well. So this is how you typically do. So iloc is the one that gives you a slice of it. What if, in this case, you don't want to limit any of the rows? You want to give all the rows, but limit only, say, columns, few columns only. Only, say, one column, this way. But here, you don't want to limit any of the rows at all. So you can do this. Simply put a colon without anything before or after. That means start with 0 and go all the way. As well here, df.iloc here. Similarly, to show all the columns and only for a specific row only, you can do this. Say 0, comma 1, all the columns, but a specific row only. That's actually another helpful thing. If you want to find out the mean average of this, it will show you for each of the columns what is the mean of that. And you can also do max, you can do the variety of things here. What if you want to do a mean of other axes? Not just mean of potato, tomato, and cucumber, but north, south, east, and west. This is where you have to give axis number. North, south, east, and west. Axis number here. What if you want to add a fourth product to it? Let's say potato, tomato, cucumber. You want to add zucchini to it. And to do that, very simple thing. df1, we simply say zucchini equal to df1. We have to add a value to that. So I'm just going to say whatever the tomatoes were, just multiply them by 1.2. By fault, I did not give this thing. So if you look at df2, now I got a zucchini column here. This wasn't there before. Zucchini column. It's a new poplet. If you want to say drop something, drop a row north here, you can simply say df1 drop north. That's it. North is dropped. So again, I just don't want to go any further because I just want to just give an idea of what Pandas is all about and how we can manipulate the data frames. Great. Now, next one we'll talk about is called Pandas Data Reader. It's not installed by default, so you have to install it by using this. So you can say let me just quit. You can say Python -m pip install Python data reader. You can probably say that because it's already installed, so I can't really do this installation. But sorry, not Python. It's called Pandas. So it's already installed. That's why you won't do that one more time. But if you didn't install it, this will of course go through the installation process or install everything. Once it's installed, let's go to Python. And I will say import pandas as pd from pandas underscore data reader import data as pdr and import date time. Okay, now I'm going to stop right here and explain to you what this is about. Let's say I want to do some stock market analysis. I want to get the data from some source and import into Python and then do some data crunching, right? Which source? Well, Google Finance is a great source. I want to extract from there. I want to extract the data from Google Finance for the stock market ticker symbol HOT, which is Starwood Hotel, HOT. I have to get everything together and do data crunching. So I have a few things I can do. I have to go to the Google Finance web page, extract the data, maybe copy and paste to some text file, open the text file in Python using the file manipulations we have shown you before, import the whole thing into some kind of a variable, and hopefully a pandas array, because that helps me do some analysis and then do the analysis. Fortunately, Pandas Data Reader, that's a module which includes all the steps. So I don't have to do all the intermediate steps of extracting from Google Finance, stored in some text file, and importing that into my Python environment. It can do everything together and import everything one shot directly from the website. So let's see how that works. Before we do that, I want to define the begin date and the end date, because that's what it will start from the begin date and it will end extracting and the end date. So let's do this. Begin underscore date equal to date time dot date time. Here I have to give all the way from 2004 January 1st. Because I have to mention a date with a year, month and date format, I have to use this module called date time. Begin date. End date equal to same thing, date time dot date time 2016 8/29 end date. All right, now I have to get the actual data. I have to put this data into some kind of a variable. Let's call that variable hot, because the ticker symbol hot equal to PDR. That's the alias, if you remember, we got from pandas data reader import data pdr dot get data Google Google. We got HOT begin underscore date starting from there and underscore date from there. It goes out into Google and gets all the data. Did it. So let's just do hot. If I do hot, it'll show everything, which is not something I want. I want to show only a few rows only. So I'll do head. Yep, we got that. Open it. The headings are like this way: open, high, low, close, and volume, etc. Different things, and for each date. See, this looks like a data frame because that's what it is. It's a data frame. It extracted everything to the data frame, and once it's data frame, I can manipulate any way I want. In this case, I am interested in only one value, that is the close. This one right here, close, because the closing price. So the date and the closing price. So let's just define another variable. Let's say called hot close equal to hot within thing here close. So this one you can say hot, how that hot close looks like. Oh, so it's too much. All right, hot close looks like this. So it has a dates and what is the closing price. One thing about that, if it's a huge variable, Pandas does not display everything. It displays only from the beginning and the end and skips in between to save space. So it's kind of cool that way to look at. If I want to find out what this hot close is, I can do type. It's a Pandas score series in this one. It's a series, and this is the attributes of the series, the dates over here. Why it is series and why not data frame? Remember, data frames are multi-dimensional, or two-dimensional actually. Series is one-dimensional. In this case, it's just one-dimensional because there is only one attribute, which is the price, closing price. The dates are not attribute of the row. It's simply a label of the row. That's the difference. All right, so we got that part. What do we do with it? Well, one cool thing we can do is that you can put in a graph and see how the price has fluctuated. To do the graph, we need a package, which is Matplotlib. We did that. So we're just going to do this. Import matplotlib dot pyplot as plt. Got that? plt dot plot hot close. Got that? And then say plt dot show. There you go. We got the stock market chart. As simple as that. And I just did a simple example of closing price. Of course, if you want to have another variable right here and say volume, etc., you can do that as well and keep on doing as many things as you want. So this is one of the cool things to show how we use data reader. And Pandas data reader is not just for Google Finance. It has a lot of other things. Take for example, it can have World Bank, OECD, Organization of Economically Developed Countries, etc. The data available, publicly available there. It can go and get it. It's a very good thing for Pandas data reader. And because it's actually available part of GitHub, people are encouraged to contribute their own sources as well. So anything that is publicly available, you can go and get that. So that things are constantly improving. I encourage you to actually go and check out the most recent copy and find out what exactly has been added since I wrote this thing. And that information is available from pandas-datareader.read.io/en/latest. That shows you everything. Okay. And GitHub is the GitHub URL shown on the screen. Next, we talk about another one, which is getting the data from a database. It's very helpful. We can do a few things. We can extract the data from the database to a flat file, a text file, and we can import the text file into Python. Yeah, it's a cumbersome, not exactly something we want to do all the time. Or similarly, if you want to write back to the database, we have to write into some kind of a text file and then use the database's utility to read that. For example, Oracle, we might use SQL Loader, etc., to load into the database. Again, very cumbersome, not something you want to do. Fortunately, Python has something called a DB API specification that allows it to have developers develop different modules which will do exactly the same thing. One such module is called SQL Alchemy, and that's not installed by default. So you have to install it by using Python -m pip install SQL Alchemy, one word. And in my case, I already installed it, so you don't install again. But this is what I do. Once you create SQL Alchemy, you can define a connection object to connect to the database. So this is how you do it. This is how, so you can say import SQL Alchemy. Done. Then you say connection, a connection object. That's where you have to give the user ID, the password, which server you are connecting to, what port number, etc. In SQL Alchemy term, we call it create engine. So you can say create SQL Oracle. By the way, you can give multiple databases actually, not just Oracle. There's one good thing about SQL Alchemy is generic, it's not Oracle specific. So whatever database you're connecting to, you have to give that vendor name. In this case, we went to Oracle // user ID HR, the password happens to be HR at localhost 1521 hyphen AL121. That's the service name. Okay, done. So this is a connection object. At this point, the connection is not actually established. It's simply a connection object. When you do an actual query, that time the connection is actually established, and Python reads the query. Once your connection is created, you want to select something out of it. So to do that, we can just say emp1, another variable, emp1 equal to pd, as a pandas, read SQL query, says select star from employees. And where do you get it from? This connection object. At this point, it is going out and reading everything. And if you do this, emp1, it shows you everything. What kind of database or the data type is this emp1? If you will be wondering, type emp1 is the data frame, which is exactly what you learned earlier, the data frame here. So this is how SQL Alchemy works. I'm not going to explain it further because this is not something we'll be using. There's a better package to use with the Oracle databases only, and that is cx_oracle. Again, it's not installed. You have to install it by using that Python -m pip install cx_oracle, like we saw it before. It uses a few things. What you just it needs Oracle client. I use the Oracle Instant Client, and that's what it has to be in the path. Specifically, what Instant Client is. You just do this import CX Oracle. Actually, Oracle CXO. You got it? That's right. So here also you have to create a connection object. So I do this way. So connection equal to CXO dot connect user ID, password, localhost 1521, the port, and the service name. Done. And if I want to find out what it is later on, I can do that using a CS. This is a CX connection this way. And if you then you can do some basic queries. One of the things you can see is that what is the Oracle version. So you can say con version 12102 and so on and so forth. Now we can do some queries on the database side. So what's important is the general steps of executing the SQL queries are: you open a cursor object, you bind a statement to the cursor object, then you execute the cursor object to fetch the results. So open cursor, bind statement, and execute cursor. That's the general three step. So let's see one by one. Let's see how to open a cursor. So you can say cursor 1 equal to con cursor method. This is it. So if you want to see what the cursor looks like, well, my fault. This is a cursor of this. There is a CX1 cursor on this connection. This is basic. It doesn't really help much. This is nothing but a cursor. It is not tied to a specific statement. Now the next step is you have to tie a statement to the cursor. So this is what you do it. So you can say cursor actually 1 dot execute select star from employees. Let's say give another where condition, employee underscore ID ID equal to 198 or something like that. So this is the connection. At this point we bind the statement to the cursor. Now we execute it. When we execute it, it's called fetch it. So you can do a few things, a few ways. You can do this way: for row in cursor 1 print. We can do this, and this is one way of doing it. So if you want to find out, you can go and find out from the database this is exactly what the query is. So this is one way of doing the fetch. But that's not the most of the things we'll be doing. We want to select maybe not just one row at a time. We may do a few rows at a time. So what we do is that in this case, you can say fetch 1. You can say it this way: row equal to cursor 1 dot fetch 1. You can see that I didn't fetch anything at all. Why is that? Because I just got only one row before, and after the one row is done, it's done. That there's nothing else to. It can't get another row. So to do this, let's just do one more thing. We can just do say we'll open the cursor one more time. To do that, we'll say cursor close. Then let's open the cursor one more time. Instead of doing employee ID, where employee ID equal to 198, we'll not do that, or not open. Sorry, I had to open it one more time. Cursor done it. Then I have to do fetch 1. Fetch 1. You can see that. And say print row. Got the first one. Let me do one more fetch 1 here. Print row. You got the next one. One more fetch 1. Print row. Next one. And so on and so forth. It will keep on fetching one by one, which is great. But sometimes it's not really good because we need to fetch a lot. We won't fetch one by one. So the corresponding one is called fetch many. And if I do this print row, it gives you everything in one shot. Fetch many. If you fetch all the rows, and it may not be very convenient to use one. You may want to fetch a few at a time. For example, you can fetch only 2 at a time. So you can see here, num rows equal to 2 or something. Oh, sorry. Num rows fetch, not fetch 1, fetch many. Num is equal to 2. Print row, it 2 at a time, it will keep on fetching it. That's exactly what might be helpful. If you do fetch 1, not fetch 1, fetch many, 2 more rows and print, it'll give you the next 2 rows and so on and so forth. This is something very similar to the array size in SQL Plus. You might have seen that, something very similar to that one. And another method to do the fetch all is you can do this row equal to cursor 1 dot fetch many, actually fetch all, sorry, and then you can do print everything here. You can define an array size, which is just similar to SQL Plus array size, by doing this way. Cursor 1 dot array size equal to 10. So it go 10 at a time. Fetch all. You see, they didn't fetch anything. Why? Because it fetched everything from before. So it's not going to fetch any more at this point. So, but to do this way, we'll close this cursor. And select star from execute from employee. Array size 10, fetch all, and print row. It gives you, but at this point it does one by one, 10 at a time, not the whole thing. So if at any point in time you want to find out what the cursor is actually you defined, you can do this way, cursor 1 dot description. This is how the cursor ID looks like. So employee ID, first name, and so on and so forth. This might be helpful if you lost track of what cursor you have defined, etc. Remember, we just did that first. We said execute the cursor, and then we do fetch all. We actually didn't have to do that. If we wanted to, we could have defined this. So rows equal to cursor 1 dot simply say execute select star from employees. We could have done that too, and print rows, sorry, just rows. So for row in rows, print row. We could have done that as well. So that way row becomes one array and containing one by one, which is sometimes very, very useful. And if you want to find out rows, what it looks like, description, sorry, rows description. This one shows you that as well. But let's just go back and see why did it give an error like this way when I give this. The reason is that if I put a parenthesis and end parenthesis after something, which means it's a function, or if I have a type dot function name, that means a method of the type. Description is not a method or a function, it's an attribute. As a result of that, I cannot put parenthesis after that. I have to use rows.description this way. Very simple thing. So far we talked about a simple query. Most likely you will not be using simple queries. You will be probably using a lot of bind variables. Suppose you have an interactive program development when you ask people to enter the employee ID and use the employee ID to select from the employee table. You can't simply keep on creating the same statement. First, it will create multiple statements. It will become difficult to do Python programming, or it will be even more stressful in the Oracle database because the shared pool will be filled with these distinct statements. Not a good idea. So you want to use something called bind variables. So to use the bind, we can use the bind variables in CX Oracle very easily. The only additional step required is that you have to do something called a prepare cursor as opposed to simply execute the cursor. So let's see how that actually works. So let me do this thing. So I'll say car1 is a cursor equal to connection dot cursor one. I'm sorry, cursor. Cursor, my fault. Cursor one. Now I have to do one more statement called car1 dot prepare select star from employees where employee underscore ID equal to, here I'm guessing, EMP underscore ID. This is how I do it. car1 dot execute, I give it here, none. Here I have to give the employee ID value of that, and the way I have to do is using a dictionary type in Python. Remember the dictionary type? That's actually a key value pair enclosed within curly braces. So this is what I have to do. Curly braces. I have to give the bind variable name, which is employee ID, and colon, say 198, and end curly brace too. So this is the end of the dictionary statements. This is it, done. Then I do fetch all. So car1 dot fetch all. Got that. Let me do one more time. Execute, not 198 but 199. Fetch all. I got 199. So that way I can use any bind variable value by using this syntax, bind variable value, colon, and the value right after that, and that's it after I got that. What if I want to find out what are the bind variables defined for this cursor? No worries. I can do this. Employee ID, that's the bind variable name. This is something you might have already seen before. Remember in PL SQL you have something called a execute immediate, also called native dynamic SQL. Execute immediate allows you to create a SQL statement out of complete just a string, and you execute that without any predefined. So you basically can create a cursor, you can create a SQL statement dynamically in a just from anything and execute that. So can we do the same thing here? Absolutely. How do you do this? Let's say create a package like this way. Suppose I need to construct this SQL statement. So let me this way. So let's call it S1 equal to select select something from here, select star from employees, and there I'm going to stop. I'm going to construct this, remember? So S1 equal to S1 plus, where employee ID equal to, I'm going to stop again, S1 equal to S1 plus, here I can't give employee ID, I give 198. So let me see S1. S1 looks like this. This is the string I constructed dynamically. I want to execute that. In PL SQL, you would have done execute immediate S1, and that will have executed this one. In CX Oracle, how do I do it? Very, very simple. Core1, let me open a cursor first. Connection, cursor, cursor. You got that? Then core1, execute S1. This is how you do it, simply. Execute S1. After the execute S1, you do fetch all. So core1, fetch all. I got it. Let me do one more thing. So in this case, S1 equal to select from employees, employee ID, instead of 198, I do 199. So I do execute S1, fetch all, 199. I keep on doing that. So this is good. What I want to do is that instead of 198 being passed as a literal, I want to pass 198 as a bind variable. Can I do it? Sure I can. Let's do it this way. Employees, employee ID, and instead of 198 as a literal, I'm going to say here column emp ID. So S1, this is emp ID. This is good. Then, so here execute S1. When I execute S1, I'm going to say non emp underscore ID 198 end parenthesis. Sorry, I made a mistake somewhere. core1 execute non-employee ID employee ID. What did I do? Non employee ID colon 198 employee underscore ID. Did I not give the employee ID somewhere? Employee ID. Okay, did I make a mistake? I guess I did. Employee ID. Select start from employees where employee ID equal to okay, got it. Execute cursor equal to, okay, I didn't prepare it. My fault. So prepare. So this is S1 looks like. I need to prepare it after opening it. Cursor 1 prepare S1 okay. Now it's okay. Now it's going to work. 198. Then I'm going to fetch all. That's going to work. Then I'm going to say one same cursor execute 199 and fetch all. I got the next one, and so on and so forth. So you can see that here I don't have to use a literal statement for dynamic SQL. I can create a bind variable as well and then keep on passing the bind variables. So far we talked about only select statements. Let's see something different. Update statements. Suppose I want to do an update. So S1 equal to, so say S1 equal to update employees set what is that, salary equal to salary into 1.5 where employee ID equal to emp underscore ID. This is S1. Let me do this. So I go to prepare S1, then let's say execute it and say instead of fetch all, at this time I'll say okay, fetch all. Not a query, sorry. This is done. I can do a commit. So I can do a connection dot commit or a rollback at this point. This is how you do an update statement as well. You can do, if you want to roll back, this is how you do a rollback as well, both sides. So this is how you can do a different way of doing SQL statements. We saw select statement, we also saw update statement. You can do both ways. I can also do how to do query. Let's do another one, insert statement. Let's see how we can do the insert data into that one. To do that, I'm going to go to SQL Plus and say SQL Plus HR and I'm going to say create table test C1 number, C2 say varchar2 1, just to show it a little bit difference. One name already used, so I'm going to say drop table test purge, create table, okay, C1 describe test C1 C2. I'm going to insert into this table using Python. So once again, you can do that, easily do that. So let's go back and do it here. So to do that, I'm going to have input data. This is the one I'm going to insert, 100 and A. Suppose this is something I have to introduce. My fault. This is a tuple, if you remember, with just a single parenthesis in this one. Then I'm going to create a cursor, which I did before. I'm just going to reuse that cursor. Score1 dot execute within parenthesis. I'm going to say, insert into test values. Here is the 1, 2. This is a positional variables 1 and 2. What are the variables, values of the variables? There I give this input data I defined earlier. I give input data. Okay, done. Execute. Then I do commit. If you remember that, commit. So if I go and take a look at here, select star from test, I got it, which is interesting. However, in real life, you're not going to get only one row at a time. Most likely, you probably get a bunch of rows at the same time. So you want to insert them. Do you have to do one by one? Array like in a loop? Kind of cumbersome, isn't it? So fortunately, you don't have to do this. This is not. So remember how we did this? We use a tuple to load data into that. We can create an array of tuples to load into that. Each tuple represents one row. So let's see how that actually works. So instead of input data being just one, we're going to define an array here, and he'll say 1 comma a. Next, 1 comma a, something like this. Then 2 comma b comma 3 comma c, and we end this. Just list 3 rows only. Then what we do the same thing here. Insert into the values, input data, exact same thing. But in this case, the only difference is that the input data variable now has 3 different tuples in there, not just one. Let's execute it. Unhandled data tuple. Sorry about that. That just didn't work that way. We should have done execute many. So instead of doing this, see, there's just execute. We have to give execute many. Done. Let's do a commit. Let's see from here. We got it. And of course, you can do a delete statement, the same thing as you did update as well. It's not that much of a difference. This is the best part of Python, inserting into the data and selecting and updating and deleting and all that thing. Finally, we'll close this with our thing, procedures and functions. If you're a PL SQL developer, you must be using a lot of procedures, a lot of functions, etc. So you want to know how we can call procedures and functions from CX Oracle. Is it difficult? Absolutely not difficult. As you might remember, procedures do not return anything. They simply take input values and they do some processing inside there. But there is also some procedures as an out parameter, which basically put the value in the out parameter to be used by whoever calls it. So we'll see the different kinds of procedures and how we use them into our advantage. So let's fast forward. I'm not going to write this. I'm going to copy and paste this. This is the first procedure. Create replace procedure proc1. See that two parameters p1 and p2. One is number, one is a varchar 2. And all I do is that if it happens, I simply put the put line p1 equal to that and p1 equal to that. Something very, very simple to do this way. I will, and then second p2 proc2 is I have an out parameter. That's the important part, out here. And in this case, I simply put the value of p2 as p1 multiplied by 2. That's it. And I also put the deviance output put line. And I also create a function called func1. I accept 2 parameters, p1 and p2, and I return p1 plus p2. So I got 3 different things. Proc1 is a procedure with just 2 input parameters. Proc2 is a procedure with 1 input and 1 output parameter. And func1 is a function that accepts 2 parameters and returns a number. Very simple thing. Let's see how we can use each one of this one. All right, so let me just go and clear it up. This one. So I want to call these functions and 2 procedures and 1 function. So to do that, again, I have to do the same thing. I do start with connection equal to cxo dot connect. This is I think I already have it somewhere. I'm just going to use it. Oh, come on, it's gone up too much. I should have typed it. All right, I should come up. Come on. There you go. then I say car1 equal to connection dot cursor. This is the thing, and then car1 dot call proc. In call proc, the first parameter should be what is the procedure name, and then second parameter should be with a tuple what are the parameters to the procedure. Say I want to give this. It returns 1 and a, because you know that's what it showed, 1 and a. Let's call the other one, which is the out parameter. Because an out parameter in the proc2, I need to create a variable to hold that out parameter. So to do that, I need to create a number variable. So I would say v1 equal to car1 dot var cxo, that's the connect cx oracle dot number v1. Then remember, this is in uppercase, it's not in lowercase. I can create any number of data, kind of variable in cxo. It could be varchar2. I have to use cxo dot string, and for characters I have to use cxo dot fixed underscore char. For date I have to use cxo dot date time, and for timestamp I have to use cxo dot timestamp. Now that is all done, let me so when this is done, I will define another cursor just to be clear, because I don't want to use the same cursor one more time. So let's see, in this case let's define cursor 2, and in this I also have to remember the cursor 1 how we call proc. Cursor 2 also will do the same thing, call proc. Cursor 2 the call proc and call proc2. Here also I give two parameters, a 1 and a. Remember that a cannot be, I have to give the variable name here, the v1, and this v1 I defined right here. See that there's a difference, the v1, I got it. So it returns v1, and if I see what the value of v1 is, print v1 up with the value 2.0. That's what it is. What if I want to give, say, 10 v1? Print v1 20.0. You can see that how the value gets updated. You can also give v1 dot get value. That's actually actually returns a value this way. Interesting. Let's see how we can call a function. Function has the same thing, but just for the sake of clarity, I'm going to create a third cursor. Cursor 3 equal to connection dot cursor. Result equal to cursor, no, not cursor, car3 dot call func. Func1, that's the function name. Cx, actually cxo. What I'm going to pass, cxo dot number. That's what the return value is. What I'm passing, let's say I'm passing 1, 1. Result 2.0. Remember that it simply passes. What if I pass like 4 and 5? 9. It adds up. Remember that function does nothing but simply adds up the two numbers. So that's how it will give it. Print result. So hopefully you got an idea of how to call functions and procedures, etc. using CX Oracle. So we just went through a whirlwind tour of multiple packages inside Python. I understand it's not a complete treatise, is for you probably, but the whole point is that to give you to give you a jump start on these packages, and also give you the pointers so you can go and explore on your own. That's the whole idea behind it. And hope I have whetted your appetite enough to see how these things are really powerful, and you can go and explore more on the different URLs given. So this brings to a conclusion of our 5-part article series on Python for PL/SQL developers. We started with the basics of Python. We gradually moved into more and more complex topics such as conditions, loops, collections, array, etc., file manipulation, and finally at the end we saw specialized packages and modules to do data analysis. Using all these things, you can create sophisticated Python packages and data analysis to become a successful data scientist. Hope you enjoyed it. Hope you liked it. And as always, I would love your feedback. Appreciate your taking the time to go through this, and hope to see you more. Happy learning. Thank you.